Hello everyone and welcome back to Just Finish Coding. My name is Sriram and this video is the fourth and final part of the Scratch Piano series. In case you haven't watched parts 1 to 3, I will leave a card for you right here. By the end of this video, you will be able to hear the sounds from the piano keys and you will also have the metronome fully ready. Okay, let's begin. We head over to the metronome sprite and begin with the init clones message. Since this is the beginning of the game, we will clear the existing graphic effects, then hide, then set the tempo to 60. As I mentioned in the last video, the tempo values are in beats per minute, so 60 means 60 beats per minute or simply 1 beat per second. Like we did for the other sprites, we will use clones here too. Since we will create new clones after this, we delete all of the clones that exist at the moment. Now for the metronome, we will be having a clone for the heading or banner, we will be having another clone to toggle it on and off, and lastly we'll have a third clone to function as a backdrop for the graphical numbers which display the beat. If you look at the costumes tab, you will see that there are 4 costumes. The first costume is the heading. The second and third costumes will alternate when the button is toggled on and off. And finally, the last costume is the place where the metronome number can be displayed. In order to identify these clones, we create a variable called clone ID for this sprite only. First, we set clone ID to heading and create a clone. Then, we set clone ID to button and create a clone. Finally, we set clone ID to number and then create a clone. Alright, let's now move on to the clone script. When a clone is created, we first of all show it. We will now identify the clone ID variable for each clone and distinguish their functions. If the clone ID is heading, we start off by moving it to the back layer. Then, we switch the costume to heading and go to position of X120, Y120. Okay, let's move on to the next clone. Here we check if clone ID is button, and if it is, then we move the clone to the front layer and then move backwards 5 layers. We then switch costume to button off. The position here will be X100, Y90. In order to create a toggling feature, we create a new variable for all sprites called metronome. If the metronome is toggled on, then this variable will be set to on, and if the metronome is toggled off, then this variable will be set to off. At the beginning, we wouldn't want the metronome beats to start playing, so we set it to off. Next, we create another variable called wait lag, but set it for this sprite only. In the last video, we used this exact same technique to set up the tempo button, and I went through the detailed logic there, so I will not do so again. Let's write the code now. We set the wait lag to 0, and within a forever loop, we check if the clone is touching the mouse pointer and the mouse is down. If yes, we check if wait lag is more than 8. If this inner condition is true, then we set wait lag to 0 and then set the brightness effect to 3. Since we're toggling, we check if the costume number is 2. This corresponds to the button on costume. If this is the case, we set the metronome variable to off and then switch the costume to button off. Within the else statement, we set metronome to on and switch the costume to button on. Great, now we can configure the graphic effects. If the clone is touching the mouse pointer, we set brightness to 5, otherwise we set it to 0. Finally, within the forever loop but outside the if then else and the if then condition, we change wait lag by 1. Okay, perfect. Those are the first 2 clones and now we can configure the last one. The code is quite similar to the second one, so we can duplicate all of it. We change the condition to check if clone ID is number and then delete the set metronome to block. This clone controls the beats and not the toggling, so that should be quite obvious. We switch the costume to number space and then go to an X position of 150 and a Y position of 90. To set up and control the beats of the metronome, we create a new variable for all sprites called metronome beat. Initially, we set metronome beat to 4. This is because 4 is what is most commonly used. We can make a small change and check if the wait lag is greater than 10. This makes no difference to the logic of the code, but since the spamming problem is not too big here, we can make this time longer. We can throw out all of the existing conditions, instead checking if metronome beat is equal to 4. If yes, we set metronome beat to 1, and if no, we change metronome beat by 1. In essence, the user will be able to choose from 4 different beat types. 4 beats then a pause, 3 beats then a pause, 2 beats then a pause, or 1 beat before a pause. Perfect! With this done, we can set up the beat number display system within the metronome number sprite. In this sprite, we will have a clone that assumes the value of the beat and then displays itself. If you look at the costumes tab, you will see numbers from 0 to 9, but we will be only using the numbers from 1 to 4. Let's get back into the code. When the init clones message is received, we will delete all of the existing clones. Next, we will hide the sprite and create a clone. Within the clone script, we move it to the front layer and show. We position it at x150, y88. Within the forever loop, we make sure that it always switches its costume to the metronome beat variable. Great! If you test out the program, you will have the full display working. Switching on and off the metronome doesn't do anything because we haven't programmed the music yet, but we can still change the beat quite easily. Okay, before we move on to playing the music of the beats, we can code the piano sounds, as this is quite easy. First, we head over to the white key sprite. When the sprite is clicked, we play the note clone ID plus 34 for 0.25 beats. To understand this line of code, you have to first understand how Scratch's piano notes work. A note of 60 refers to middle C. Note 59 will be the key right before, and note 61 will be the key right after it. For our own piano, we have each key with a unique clone ID. The 26th note is what we will be using for middle C. So for a clone ID of 26, the note played should be 60. For a clone ID of 27, the note played should be 61. You probably get the idea now. Whatever the clone ID is, we add 34 to that and then play the resultant note. We can throw in the same code into the black key sprite as well. That is all you will need to do to hear the piano play. If you test out the code, you should hear the notes when you play them. Great, the last thing we have to do is make sure the metronome plays as well. So we head over to the beats sprite. When the init clones message is received, we stop all the sounds. To control the beats, we create a variable for this sprite only called beat number. Initially, we set beat number to 0 and metronome to off. The beats should only be played if the metronome is toggled on. So, within a forever loop, we check if metronome is on. If yes, we change beat number by 1. Then we play the drum wood block for 60 divided by tempo multiplied by 0.5 beats. Here we're creating an inverse link between the tempo and the amount of time each beat will play. The greater the tempo, the less the time between 2 consecutive beats, and the smaller the tempo, the more the time between 2 consecutive beats. You can play around with these numbers, but I think these work out pretty nicely. After this, we check if the beat number mod metronome beat is equal to 0. The best way to understand this condition is through an example. Let's say that the metronome beat was 4 because the user wanted a pause after 4 consecutive beats. The beat number changes by 1 each tick, so we only pause when the beat number is at the count of 4, 8, 12, 16 and so on. When the beat number is divisible by 4, we pause. Since the metronome beat can be anything and not just 4, we pause whenever the beat number is divisible by the metronome beat variable. The time lag that we give here must be inversely proportional to the tempo. So, we wait an additional 1/5 of the duration of a beat. Thus, we wait 60 divided by tempo multiplied by 0.1 seconds. Within the else statement, we set the beat number to 0 as we do not want any beats being played. And that is everything you need to do to get a fully functional piano. If you test out the program, you should see that the metronome works beautifully. If you've enjoyed making your piano, then make sure you click on the playlist on your screen right here, as that will take you to a brand new simulation-based series. Thank you so much for watching, and I'll see you in the next video.